Hello, everybody. So today we're going to finish up the first section in our finance unit. So when we left off, we had just started to discuss um, compound interest. So we took a look and we found that compound interest, in fact, is an exponential function. And simple interest that we learned previously is, in fact, a linear function. So um, you're going to get more interest out of using some sort of account or investment that uses compound interest compared to simple interest. And that's what we did. And we also saw the formula to do so. So today what we're going to take a look at is there's a really nice tool um, that can do a lot of these calculations for us. And it's called the TVM, or the time value of money solver. Um, some calculators have it. Most likely you'll need to Google something on your phone or on your computer to use it. Um, all you need to do really is Google TVM solver. I think the first one that I found, the very first link on Google, gave me this one here at fncalculator.com. It's not the only one out there. You don't have to use this one. Some of them might look slightly different, but for the most part, they should all be the same. Okay, so essentially what um, this does for us is it sets up and calculates using our um, compound interest formula for us. But we have to kind of um, we have to know how to use it properly. Okay, so as you can see here, there's a few different fields we can enter, especially if you go to the advanced version. Um, it gets a little confusing. So we can go through some of these and hopefully it'll all make sense when we're done. So the first thing is a period, um, pretty much our t value that we were using previously. Sometimes the solver calls it the n value. Okay, so for something that, or um, for a loan or an investment that compounds annually, it's just going to be the number of years, right? Because it's going to compound once a year because it's annually. In the next section, we're going to take a look at. Um, Actually, no, we already took a look at things that don't compound yearly, right? Oh no, sorry. In the next section, we're going to look at compound interest questions that don't compound yearly. For now, they will compound yearly. So for now, think of the period as just the number of years. Okay. The interest rate, it's the same as always, right? This is our R value. Um, the only thing to be careful with here is sometimes the solver will let you use a percent when you enter it, whereas usually when we were doing this calculation by hand, we had to convert it to a decimal. So just be careful when you take a look. For example, here, um, I have the annual rate right there, and it is asking me to give it as a percentage. So if we had to do something here with a compound interest rate of 7%, I would just enter 7 and not 0.07. So just keep an eye out for that. The present value, that's sometimes called the PV value with these solvers. That's just our principal amount. Okay, that's what we're starting with. Usually we'll leave it as a negative value because it's usually money leaving our pocket, right? Like with an investment, right? If we're gonna go start an investment, we're gonna give the bank, however much money we're investing, right? So it's gonna leave. So if you're giving that money to somebody, such as the bank, make sure you leave it as a negative value. Um, PMT, the PMT value, that's the payments. This field represents you putting money in after the initial amount, after the principal amount. We're not going to be using it in this section. We'll use it in a later section. So for now, just leave it as 0. Don't put anything in. Okay. The final value, that's our A value from before. That's just how much money we have when we're done. And these next two, again, we're not going to be dealing with them in this section. We will be dealing with them in the next section. So sometimes you'll see a payments section or payments per year. Again, that's how many payments we make after. For now, we're not going to use it, so don't worry. Compounding periods per year, we're going to be using this a lot later. Sometimes they call it C/Y, or sometimes you'll just be able to specify it. For example, in this one, where it says compounding at the bottom there, that's what this question, or that's what this value is talking about here. All it is it deals with how many times the interest is compounded in 1 year. So if a loan is compounded annually, that means once a year, that value would be 1 because it's compounded once in a year. If the interest is compounded every month, that value would be 12 because it would be compounded 12 times in the year, once every month, right? We're going to talk about that more in the next section. I'm not going to worry about it now. And then there's usually an end/begin function. For now, just leave it as end. It talks about the timing of the payments. We're not going to really deal too much with that, so we can leave it there. Okay, so let's do an example just so we can kind of see what's going on. So we have a question. Amber invested $8,000 for a 5-year loan compounded annually at a rate of 7.25% per year. Determine the value of her investment at the end of the 5-year term. Okay, so as you can see here, this is the same solver I was using from that website. So again, lots of important information. So the PV value, that's our present value. That's what we're starting with. That's our principal amount. So in this case, as you can see, that's the 8,000. That's what we're starting with. Notice I put negative because Amber is taking her $8,000 and giving it to the bank. Okay, that's coming out of her pocket. She's not making any more payments to that investment after she started. So we're leaving that as 0. Okay. This future value, or this FV, that's the final amount. That's what we're going to try and solve for. So we'll come back to that in a second. The annual interest rate. Okay. That's just our R value, as always. Like I said, this particular solver does not require me to enter the interest rate as a decimal. We leave it as a percentage. Okay, so just 7.25, not 0.0725. The periods, again, this is our T value. So Amber is letting the investment sit for 5 years. Okay. And we are compounding this annually. Okay, so we're leaving the compound period to be annually. So if it's compounded annually and she's leaving it for 5 years, that means we're getting 5 compounding periods total, once every year. Okay, so what we would do is we would come over here and we would click that button and it would show us the future value. So we can come in here. So it's a negative 8,000. Payments is 0. Future value we're going to find out 7.25 as the interest rate. There is 5 periods and it's compounding annually. So we'll go in, click the FV button, and we get a value of 11,352 and 11 cents. So essentially what that calculator did, used our compound interest formula for us and came to a final value of this number. Notice that the 11,352 and 11 cents is positive. That means that's money going in to our pocket. So we initially gave the bank 8,000 out of our pocket. It was negative. After 5 years, the bank is going to give us 11,352 and 11 cents into our pocket. So it's a positive amount. Okay. We can do one more. Yeah, clicking the FB button is going to give us that value. Okay. Yeah, I think that's all I want to say about this. Like I said, we're going to get a little more in depth with the TVM solver in the next section, but for now, that's okay. Last thing we're going to talk about for the first section is we're going to talk about what's called the rule of 72. And what the rule of 72 is it's a rough calculation that's used in compound interest formulas that approximates how long it's going to take for an investment to double. Okay, so we have the formula here. So the number of years we have to wait for the money in an investment to double is 72 divided by whatever the annual interest rate is. Okay, so we can do a quick example here. So the time it would take to double would be 72 divided by the annual interest rate, which is 9%. Right? So if you go in and do 72 divided by 9, see that's 8. So if you're getting an annual interest rate of 9%, it's going to take 8 years for your money to double. Right? So if you invested $2,000 for 8 years at 9%, it would double to 4,000. Okay. We can go the other way as well. Okay, because we can take this formula if we want to get the annual interest rate. All we would have to do would be to switch those two values, right? So our annual interest rate would be 72, oops, not 77, 72 divided by years to double. All right, so you take 72 and divide it by the 12 years to double. We would get our annual interest rate, of course, that would be 6%. Right. And down here as well, same thing as the first question. So that would give you 18 years to double if you were getting a compound interest of 4%. Okay, so it's just a quick tool, quick estimation. It's not exact, but it does get you quite close. Okay, and I think that's it. Oh no, one last question. Okay, use the rule of 72 to estimate the number of years it would take for an investment of $1,000 to grow to $8,000 if the annual interest rate was 7.2%. Okay, so here we start at 1,000, here we start at 8,000. So obviously 8,000 is not double 1,000, right? But we can see how long it's going to take for our $1,000 to grow, right? So if the annual interest rate was 7.2%, so we can do 7.2, or sorry, this is weird because it's a rule of 72 and the interest rate is 7.2. So we'll do 72 divided by 7.2, and that gives us what we require for our first doubling, right? So if you do that, of course, it's going to give you an answer of 10. 10 years to double. So that 1,000 becomes 2,000. And then we can do it again, right? Divided by 7.2%. Of course, it's going to give us another 10 years. So then our 2,000 goes to 4,000. And then it would double again. And then our 4,000 would go to 8,000. So we needed to double 3 times in order to go from 1,000 to 8,000. So if we needed to double 3 times, and we used the rule of 72 to calculate that a doubling takes 10 years, 3 times 10 years total is going to give us 30 years for the investment. To grow from $1,000 to 8,000. Okay. All right, so that's all for the first section. Next week, we're gonna jump into the next section. All right, so you can go ahead and you can actually do, I think what I did, I said to ignore the TVM solver for question 9. Don't do that. I do want you to do all the questions now on page 507, 1 to 9. Okay? So go ahead, give it a shot, and I'll see you guys next week. Bye.